Okay, we're going to take a look at the development of the unit circle value. So what I drew over here was my same two special right triangles. I used degrees, radians isn't going to matter. We still have the same side relationships. And what we're going to do is look at the different trig values. Again, sine, cosine, tangent, cosecant, secant, cotangent in relationship to that unit circle. Right? So a unit circle is a common way to deal with these. Unit circle values. So first off, the unit circle equation is x squared plus y squared equals 1. So from back in algebra, this would mean that the center is at 0, 0, and the radius would be 1. Right? Center's at 0, 0, and radius 1. So that would mean that, kind of take a look here, just some generic circle. Well, that means that this length is 1, this length is 1. Again, I'm not the best drawer, but you get the idea. Anything off the center, that radius is going to be 1 unit going around. Okay? Now, what happens at these places where it's 1, we actually develop these right triangles we're going to go take a look at here. But still, we call it a unit circle because the radius is 1. Center at that 0, 0. Okay. Now, that being said, I'm just going to draw one a little bit bigger here so I can kind of work with. Again, won't be the best looking circle, but we get the idea. Okay. So this point would be 1, 0. This point would be 0, 1. Negative 1, 0. And 0, negative 1. And so if we talk about going around the circle, we're at 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees, or if we're in radians, 0, pi halves, pi, 3 pi halves, and 2 pi all the way around. So to kind of look where this development comes from, we have our special angles going in here. This would be pi 6, pi fourths, and pi thirds. Now, I use degrees over there, just kind of mixing the two up. We got to get used to using both, so I'm just going to use radians in my circle here. And so I'm looking at this angle right here, at this pi 6. So the idea would be, if I were looking at this 30-degree angle, which is pi 6, let's say I'm trying to fit it into my circle there. The issue that I run into is the radius here is 1, right? That hypotenuse there is 2. So in essence, that triangle is too big to fit into the circle I've drawn. It's too large to fit into. So I'm just going to kind of redraw it right here, just kind of give us an idea. So I don't have to mess with my 2 over there. But here we go. 1, root 3, 2. There's that 30 degrees. So what I'm stating is this particular triangle won't fit in here because this side's too long. So this is the hypotenuse 1. And again, 1 because it's the unit circle. This is 2. So I want to scale this guy down. And for me to scale a triangle down, if I would like this to be 1, I can divide it by 2. And it will maintain the proportionality of the angles if I divide each side by 2. So I've scaled down that triangle so that it will fit in here now. So this becomes 1. This would become root 3 over 2. And then this part up here would be a half. That makes this ordered pair root 3 over 2, 1/2. Right, so that point would be going right root 3 over 2, up 1/2. So I've scaled this triangle down to fit into my unit circle. That's where I get this ordered pair value for my unit circle. Okay. Now let's look at pi fourths. Erase this here. So here comes my pi fourths angle. We're going to go up here, There's a pi fourths. This is still a 1 because it's a unit circle, so that's still my value of 1. So I'm going to redraw my special right triangle here. So I'd have root 2, 1, 1. There's for that 45 degrees, or pi fourths. So this has a root 2 hypotenuse. This has a 1 hypotenuse. So I want to scale this guy down to where it has a 1 hypotenuse. So I'll divide this by root 2. That gives me a value of 1. And I can do that as long as I scale the other two sides down. So they would be 1 over root 2, or if rationalized, root 2 over 2. So this would be root 2 over 2 across and then up, root 2 over 2, making this ordered pair root 2 over 2, root 2 over 2, root 2 over 2, and root 2 over 2. That gets me that ordered pair. Now let's take a look at the pi thirds one. So basically we are relating our two special right triangles into the unit circle. So here comes that pi thirds. I want that to be a 1. Radius is still 1. So pi thirds is 60. So basically we're just going to stand this triangle up on its end here. So it looks kind of like this. Put the 60 down here. That would be that pi thirds. That's still 2, a 1, and a root 3 side relationship. And so once again, I want to scale it down. I don't want a 2 hypotenuse. I want a 1. So that means I divide this side by 2, which would give me a 1. And then if I scale it down, each of those are divided by 2, giving me a 1/2 and a root 3 over 2 on my triangle. And so then here is my ordered pair, 1/2 and root 3 over 2, that piece. That's where it's taking those triangles and putting them into my unit circle there. Now, get rid of this triangle and let's kind of take a look at what's going on here. Now, one of the things that's going to help us is just to be able to kind of relate and kind of make sure that we can redraw something. We kind of have an idea of what's going on as far as developing it later. The better I can understand how something shows up, the better I'll have it getting things down. Okay. So let's kind of take a look here. 1, 0, 0, 1, and look in between. Notice they're all over 2. You can think of it as, look, there's root 1, root 2, root 3. Root 1 is 1. Come back up the other way. Root 1, root 2, root 3. So forth. Now, if I go into the second quadrant, I have a point here. That would be 2 pi thirds. One here would be 3 pi fourths. And then right here would be 5 pi 6. And I'm going to come up with these values. Now, if I were to draw the triangles back in here like I did over in the first quadrant, they're going to look the same. Right? The key is going to be what we call a reference angle. So that pi 6, that's referring to the reference angle. Pi fourths refers to the reference angle. Pi thirds refers to the reference angle. So these guys are at the same angle. 5 pi 6 is at the same angle as pi 6. 3 pi fourths, same angle as pi fourths. I mean, my drawing might not be perfect, but you can see the denominator. So 2 pi thirds will be at the same as pi thirds. So that's going to move me into this quadrant. Now here's my values for this quadrant. My values for this quadrant would be negative 1/2, root 3 over 2, negative root 2 over 2, root 2 over 2, negative root 3 over 2, 1/2. Negative root 3 over 2, 1/2. Like, well, you know, how did I come up with that? I'm thinking back to algebra. Remember, first quadrant, everything's positive. If you move into the second quadrant, the x value is negative, the y value is positive. So all I did was negate. each of the x values. Notice they're the same absolute value of these because they're the same denominator, same reference angle, same absolute value. However, the x coordinate's negative. So that means when I go into the third quadrant, say 7 pi 6, there's that pi 6 reference, or special angle again, but this time they're both going to be negative. And both negative because I'm in the third quadrant. And so then when I come around to the fourth quadrant, 11 pi over 6, now just the y is negative. So this would be root 3 over 2, negative 1/2. So you kind of get the idea. These values are going to repeat. Whether or not they're positive or negative depends on what quadrant we're sitting in. So here would be 5 pi fourths, both negative. Here would be 7 pi fourths, root 2 over 2, negative root 2 over 2, so just the y is negative. And we'd have our thirds, so we're looking at 4 pi thirds and 5 pi thirds. Still that same reference angle. So we would have both negative here, negative 1/2, negative root 3 over 2. And on 5 pi thirds, positive 1/2, negative root 3 over 2, that y value negative. That's the development of the full unit circle. And basically, we're trying to get these guys down. Okay? And then where we are is going to determine the negative. So if we're in the second quadrant, the x value is negative. Third quadrant, both are negative. Fourth quadrant, just the y value is negative. Where this can help us with our trig values. Okay. Cosine of some value theta is x over r, but in this case, r is referring to our radius. Remember, this was a unit circle, so the radius was 1. Since it's a unit circle, it's x over 1 or just x. Sine is, I'm just going to put theta for some generic angle. Y over r, sine's the y value. And in this case, again, r is 1. So it would be just y over 1 or y. Now the reason that the cosine is the x value and the sine's the y value, just look on the grid here. Okay? No matter where you were on the grid, just draw an xy plane here. Let's say I'm right here. Well, that's the x value, that's the y value, and this would be the r value. All right, so the radius of that circle going around. All right? But if my radius in this case is 1, that's going to make cosine adjacent over hypotenuse, x over 1, sine, y over 1, opposite over hypotenuse. Tangent then would be that y over x. So there's how we're making that transition from just some generic triangle to going into the coordinate plane. In the coordinate plane, the x's are always going to be the adjacent. I don't care where you draw the angle. There's x, there's y. X would be the adjacent to this guy. Y would be across. Now look at the values. Now we've looked at the special angle values before as far as sine, cosine, tangent. Now look at this. Cosine of pi 6, root 3 over 2. Sine of pi 6, 1/2. Cosine of pi fourths, root 2 over 2. Sine of pi fourths, root 2 over 2. Cosine of pi thirds, 1/2. Sine of pi thirds, root 3 over 2. That's where my pieces are coming from. Tangent. Tangent, it takes us a little bit more, but tangent, y over x. So it would be 1/2 over root 3 over 2. So the tangent of pi 6, the 2's would cancel. If you think about it, you'd have 1/2 over root 3 over 2. And then you'd invert and multiply. That's why the 2's would cancel. So then tangent of pi 6 would be 1 over root 3. Tangent of pi fourths, root 2 over root 2, which is 1. Tangent of pi thirds, root 3 over 1 is just root 3. That piece there. So these are actually laying out all the values here for that part. The only thing that changed when you came over here was whether or not it was positive or negative based on the quadrant. Right? So what we want to remember is cosines x, sines y. Right? I can remember it by alphabetical order. Same reason, say, domain was x and range was y. Cosines x, sines y. Remember that alphabetical order. So I actually have all of the cosine values going around, and I actually have all of the sine values going around for that piece. So that's our development of our unit circle, taking our special right triangles and putting them into that unit circle.